So today we're going to take a look at how to calculate molarity. And of course, the name molarity comes from the term moles. So to do that, we're going to first have to review mole conversions, a little bit of review from first semester. So to do that, we have a set of review problems here, and I'll do the first one in each set so you can see how to do these. So just like we did first semester, we're going to write down what we're given. 1.50 moles of sodium hydroxide, and it's just a 1 fence post conversion. We're looking for grams, so that's what's going to go on top. Moles will go on the bottom so that they divide. 1 always goes with moles. Grams comes from the periodic table. So we're going to look up on the periodic table sodium, oxygen, and hydrogen and add them all together. And you should end up with 40 grams. So then we'll take 1.5 times 40, and we end up with 60 grams of sodium hydroxide. Then we can also do the opposite. We can change grams to moles, which is what you more often have to do with molarity problems. So 12 grams of sodium hydroxide is what we're given, so that's what we'll start with. Draw our conversion line. Moles goes on top, because that's what we're trying to find, and grams goes on the bottom. Those units cancel out. 1 always goes with moles. Then grams is going to come from the periodic table, and it just so happens these examples are the same example. So when we add up sodium, oxygen, and hydrogen, we're still going to get 40. But it's not always 40, it just happens to be sodium, oxygen, and hydrogen again. These other molecules will have different masses. So in this case, we're going to divide 12 divided by 40, and we end up with 0.300. That keeps our significant figures, moles of sodium hydroxide. So go ahead and do those other ones just for a little review, and in my next video, I'll show you how to calculate molarity.